Hello everyone, I am going to present my project on health insurance cross-sell prediction, which is a classification based project. We have been provided with health insurance dataset. We build a sample model using the health insurance dataset to predict whether the customer would be interested in vehicle insurance or not. Basically, we want to predict that will the customer from past year also be interested in vehicle insurance provided by the company. So this is the GitHub link for my project. Then moving further, in this project I aim to build a model to predict whether a customer would be interested in vehicle insurance is extremely helpful for the company, because it can then accordingly plan its communication strategy to reach out to those customers and optimize its business model and revenue. So these are the important libraries that I'll be using for my project. These are the machine learning libraries. Then for loading my data, first I connect my Google Colab notebook to my Google Drive. Then with the help of this, I have mounted my data. Then with the help of read CSV, I have loaded my data set, and I have given my data set the name data df. So this is the first look of my data set, which is this. So from here we see that my data set consists of 3,81,109 rows and 12 columns, and which are ID, gender, age, driving license, region code, previously insured, vehicle age, vehicle damage, annual premium, policy sales, channel, vintage, and response. Then for the first 5 rows, to see the first 5 rows, I have used the dot head function, and similarly for last five rows, I have used dot tail function. Then as we know that my data set consists of 3,81,109 rows, and the column contains 12 columns. So to get the information about the data type and the number of non-null values in my data set, I have used .info function. So from here we can see, like, there are no null values in any of the column, like all the values are non-null in each of the column. And there are my ID column has the data type int, and gender has object data type. Then age has again int data type. Then driving license is also int type of data. Then to check the number of duplicate values in my data set, I have used .duplicate.value counts. So from here we can see that there are none duplicate values in my data set. Like all the values are different, like 3,81,109 non-duplicate values. Then to check for the missing values or the null values in my data set, I have used isAny.sum function. So as you already discussed, there are no null values in my data set. Then as for the visualization, I have used sns.heatmap, as we can see none of the values are null. So from the above data processing, we can clearly say that our data set contains 3,81,109 rows and 12 columns, and we do not have any null values in our data set. We have 4 numeric and 5 categorical independent features, and our dependent feature is a categorical column, which is the response. Then to know what are the names of the column in my data set, we have used .columns method. So from here we can say that the names of the columns are ID, gender, age, driving license, region code, previously insured, vehicle age, vehicle damage, annual premium, policy, sales channel, vintage, and response. Then to describe my data set, I have used .describe function. So from here we can tell the about the count, mean, standard deviation, minimum and maximum, 25 percentile, 50 percentile, and 75 percentile value of the data set, about the of the column. So from here we can see that the ID has a minimum value of 1 and the maximum value is 3,81,109. So it means that all the values are unique in ID column, and the age of the people who are having a driving license, they have the minimum age of 20 and the maximum age for in this data set is 85. Then and so on, we can see about the others. Then the variable description. So the ID column in our data set, it tells about the unique ID for the customer. Then gender represents the gender of the customer. Then age represents the age of the customer, and the driving license represents the binary values. So if the value in driving license is 0, then the customer does not have a driving license, and if it is 1, then the customer already has a driving license. Then the region code, it represents the unique code for the region of the customer. Then for previously insured, again it represents binary values, and the value if the previously insured value is 1, then the customer already has vehicle insurance, and if the value is 0, this means that the customer does not have vehicle insurance. And if vehicle age represents the age of the vehicle, then the vehicle damage, again it is a binary data set data, which represents, if the value of vehicle damage is 1, it represents customer got his or her vehicle damage in the past, and if the value of vehicle damage is 0, it means that the customer did not get his or her vehicle damage in the past. Then the annual premium, it tells the amount customers need to pay as premium in the year. Then the policy sales channel, it is the anonymized code of the channel of outreaching to the customer, that is different agents, over mail, over phone, in person, etc. Then vintage represents the number of days customer has been associated with the company. Then the response column, it represents the binary data, which if the value of response is 1, then it means that the customer is interested, and is if the value of response is 0, this means that the customer is not interested. So from here we can see that we have many categorical data, which is driving license 1, second is the previously insured 2, the vehicle damage 3, and then the response also is the categorical column. So uh, these 5 are the categorical data in our data set. Then to check the number of unique values in our data set, we use n unique function in all of the columns in our data set. So from here we can see that ID has all the unique values, whereas gender has 2 unique values. So does driving license and the previously insured, then vehicle damage and response. Uh, un- uh, these all have the 2 unique values in it. Then moving further, we will do the data wrangling. So as we didn't had any null values or any duplicate values, so not much of the wrangling is done. So we just make a copy of our original data set by the name df. So we do it so that our original data does not get affected on further analysis or processing. So then we do the analysis part of our data set, and we do it with the help of data visualization. So the first chart 1, it represents the plot of responses. So if the response is 1, it represents yes, and for 0 for no. So from here we can see that most of the values are no, and only few values are 1. So it is a highly imbalanced data. So we'll have to fix this, and we'll do this further, later. So from here we have clearly seen that only less people are interested in having a insurance. So moving further, the chart 2 represents the pie chart. Chart 2 represents a pie chart for willing males and females. So from here we can see that only 39% of females are willing to have a health insurance, whereas 61% of males are interested in having a health insurance. So to increase these numbers, we should put on some offers and like interest on our health insurance, so that more people are interested in having a health insurance. And we should tell them about the importance of having a health insurance also. Then the chart 3 represents the count of male and female and response in male and female category. So first we'll see that what is the count of male and female in our data set. So we see it is not a huge there is not a huge difference between the number of male and female. The ratio is like uh, not very difference between the ratio. But as we see the response, so the more males are interested in having a health insurance as compared to females. Like very less females are interested in having a health insurance. And so, but overall the both the males and females are not very much interested in having a health insurance. So to gain the interest of the customers, to attract more people to having a health insurance, the company should put on some offers and provide the knowledge to the customers for having a health insurance policy. Then the chart 4 represents the plot of average age versus responses. So from here we can see that there are huge number of people below the age of 30, but only few, like very few, are interested in having a health insurance below 30, whereas the people above the age of 30 are more interested in having a health insurance. So this is the reason could be lack of experience, less maturity level, and they don't have expensive vehicles yet. People aged between 30 to 60 are more likely to be interested. So the chart 5 represents the preference of previously insured people. So from here we can see that the people who weren't previously insured, they are now interested in having a insurance, whereas the people who were previously insured, they are not at all interested in having a health insurance. So we should tell the people about the importance of having a health insurance if you meet an accident or whatever it is. So we should the company should tell them about the importance of having a health insurance to gain more interest of the people. Then the chart 6 represents the preference of people owing a driving license. So the people who does not owe a driving license, they are not at all interested in having a in having a insurance also. But the people who are having a driving license, they are somewhat interested in having a health insurance also. So this could be the reason that the are people don't know much about the health insurance. So the company should tell the people with driving license must have health insurance, and the people without driving license should also have the health insurance, so that they should be aware about all these things. Then the chart 7 represents the responses of owners based on their life of their car. So this bar chart represents the responses of owner based on life of their car. So the people between the age of 1 to 2 years of their vehicle age, they are more interested in having a driving license as compared to the people with age less than 1 and more than 2. So the customer with vehicle age between 1 to 2 years are more likely to be interested as compared to the other two. The customer with the vehicle age less than 1 year have very less chances of buying insurance. So Moving to the chart 8, it represents the distribution of the annual premium. So from this plot we can see say that this is the highly skewed data, and with the help of this box plot we can see that there are many outliers present in our data. So moving further, the chart 9 represents the correlation heat map. So we can see from this correlation heat map that basically our correlation heat maps are used to find potential relationship between variables and to understand the strength of these relationship. So from here we can see that this that the response is not very affected are not very correlate is not very correlated to previously insured, and policy sales and age, they are very less correlated. Then moving further, we make a pair plot of this data set. So the pair plot allows us to see both distribution of single variables and relationships between two variables. We can see the relationship between all the columns with each other in the above chart. Then we'll move further to the data preparation part. So first we'll do the changing of categorical values to binary form, that is 0 and 1, using label encoder. So we'll change the gender into the binary form, the vehicle age into the binary form, and the vehicle damage also in the binary form. So this is how it looks like after implementing the implementing label encoder. Like the if the value of 1 in the driving license data column is 1, then it represents that the customer have a driving license. If the value is 0, then it would represent that the customer does not have a driving license. And same for the previously insured, if the value is 0, that means the customer was not previously insured, and if it is 1, then it represents that the customer was previously insured. Then moving further, we'll separate our dependent and the independent variable. So my y variable, it consists of the dependent variable, which is the response. So response here is our response here is my dependent variable, and the variable x, it represents the independent variable. So all the columns except for response, these they come under the independent variable. Then we'll do the feature selection. So feature selection is basically done like to see which all features do we want in our further data preparation or modeling. So from here we can see we can find this with the help of extra tree classifier using a class inbuilt class called feature importances. So we use inbuilt class feature importances of tree based class to find the importance of the feature. Then we plot a graph of feature importance for better visualization. So from here we can see that the data license, it is very less significant. So we'll drop this data driving license from our data set, as it is very less significant for our model handling. Then we'll do the handling of class imbalance. As we previously said that our data is highly imbalanced, so we need to fix it to for further processing. So first what we'll do is, with the help of random oversampler, we'll do the oversampling of our data and oversampling of data in the minority class and make it equal to the majority class. So from this bar chart we can see now the value the data in both the responses 0 and 1 is same. So we have fixed the data imbalance of our data set. Then we'll split our data set into train and test split. So for that we have taken the test size as 30%. So it means that the 30% of the data set is the train, is the test data, and the rest is the train data. Then we do the model selection. So first we have taken the logistic regression. So basically a logistic regression is a classification algorithm that predicts the probability of an outcome that can only have two values. And we'll see that how well we have predicted our model. So with the help of accuracy and ROC score, we can see that how well we have predicted our model. So for the logistic regression, the accuracy is 78% and the ROC score is 83%. So by this 83% ROC score, we means that 83% times the model was able to distinguish between the classes, and the accuracy is 78%. The F1 score is for true is 82%. Then we'll visualize this ROC curve. So the ROC curve is the graph between false positive response and the true positive response, or we can say it is a graph between precision and recall. So if the false positive is more, then the precision is less, and if the false negative is more, then the recall is less. So then we'll make a confusion matrix. So with the help of SNS.heatmap, we have made this confusion matrix, which represents this part represents true positive, this one represents the false positive, this one represents false negative, and this one represents the true negative. So we can see that our true negative is very high, but the true positive is also very high. And then we have seen that the accuracy in our with the help of the accuracy of our model with the help of logistic regression was 78%. And by accuracy we means that it is a ratio between true positive plus true negative divided by false positive plus true negative. So then moving further to improve our model, for further model selection, we have taken random forest classifier. So the random forest classifier method is used to reduce the variance and achieve better accuracy. Random forest method can handle large data set and maintain accuracy and find missing data. So with the help of random forest classifier, we have attained an accuracy of 94% and the ROC score as 95%, which is quite good for our model. So we can visualize this from here, that the ROC curve is like this, and from the SNS.heatmap for the confusion matrix, we see that our false negative is very high, which means we have very less recall, and the false positive is less, so it means we have a very good precision. Then we'll do the XGB classifier, which stands for extreme gradient boosting. So it reduces the overfitting in a model. It do the parallel processing, which makes it faster. It also helps in handling missing data. So with the help of the XGB classifier, we have attained the accuracy of 81% and the ROC score is 83%. And so we have so this is the ROC curve for the XGB classifier. Then this is the this is the confusion matrix for XGB. Then from here we can see that our value for true negative is very high, even more than the true positive. Then comparing all the models by writing all the results in one table, we see that for the accuracy for logistic regression is 78%, for random forest it was 94%, for XGB classifier it is 81%, and for the recall value for logistic regression is 97%, and for random forest it's 99, XGB classifier it's 93. And the ROC score for the logistic regression is 83%, for random forest it's 95, and the ROC for XGB classifier it's 83%. So from this ML model for the problem statement was created using Python with the help of the dataset, and the ML model created with random forest and XGB classifier model performed better than logistic regression models. Thus, for the given problem, the models created by random forest and XGB classifier, random forest classifier is the best modeling technique as it has an accuracy of 94%. So at last, to conclude my project, I would like to say that most of the customers are unwilling for getting a vehicle insurance, so the insurance company should uh, put on some offers and tell about the importance of having a health insurance. Then more males are interested in getting insurance, which is 61% as compared to females, which is 38% only. Then then people of group 30 to 50 are the most interested in getting a vehicle insured. Then the customers who have vehicle age of 1 to 2 year are most interested. Then the customers with driving license are also interested in having a health insurance. Then features like vintage, annual premium, age are impacting the target variables the most. Then comparing the models on the basis of ROC curve, accuracy, precision, F1 score and recall, the random forest is giving the best results. Thank you.